Today's video, we're going to talk about solving inequalities. The first thing we want to make sure everybody knows is what is an inequality? Well, there are 4 types of inequality. So this symbol stands for less than. Now, if I take that symbol and I put a little bar underneath of it, that stands for less than or equal to. Then if we flip the symbol over, instead of being less than, that one is greater. Or if I put the little bar underneath of it, then it's greater than or equal to. And then, of course, with inequalities, besides solving it, you do have to graph your answer on a number line, because it's not like an equal sign where only one number is your answer. An inequality will give you a range of numbers that can be your answer. So let's jump into number 1. I would start by using the distributive property. So negative 12x plus 4 plus 6x is greater than or equal to 16. Then combine your like terms. So negative 12x and positive 6x will add together for negative 6x plus 4 is greater than or equal to 16. Then we have to get rid of the plus 4 by subtracting 4. So negative 6x is greater than or equal to 12. Then we're going to get rid of the negative 6 by dividing both sides by a negative. Now, before we go any farther, we're going to stop because there's one rule we have to make sure that you can remember, or if you don't remember, that you know from here on out. So I'm going to write the rule off to the side. If you divide or multiply both sides by a negative number, you must flip the inequality symbol. So right now, we divided both sides by negative 6, so we're going to flip that inequality from greater than or equal to less than or equal, and then divide out for negative 2. Now, to graph on a number line, my answer was negative 2, and then I'm going to put negative 1 on the right side because negative 1 is larger than negative 2. And I'm going to put negative 3 on the left side because negative 3 is less than negative 2. And now we're going to talk about how do you graph that on a number line. If you have the or equals to, then that means you have to graph with a closed circle. If it doesn't have the or equals to, that means you're going to graph with an open circle. So for us, we have the or equals to, so make sure you put a filled in closed circle. Now you have to decide, are we talking about all the numbers to the right of that circle or to the left of that circle? And if we're saying less than is to the left. So you should be shading in the left part of the number line. And there is my solution for the graph. So now pause the video and take a minute and try it on your own. So hopefully you got the same thing that I did. If you did not leave your answers as a fractions, if you wrote them as a decimal, that's okay. Just take my fraction, make sure you divide it out and see if it's the same thing as your fraction. So let's move on to our next example. For this one, I have variables on both sides. So I'm going to start by subtracting negative 1.5x on both sides. So 2x plus 19 is greater than or equal to negative 7. Then subtract 19 on both sides. So 2x is greater than or equal to negative 26. Divide both sides by 2. Now, the question to you, do we have to flip the inequality? Yes or no? And here's the correct answer. The correct answer is no, you do not, because in this problem, you are dividing by a positive 2. It doesn't matter if the top number of the fraction is negative. What you have to focus on is that bottom number of the fraction. And that bottom number is a positive 2, so we are not changing the inequality. So you should have x is greater than or equal to negative 13. So then here's my number line. And we have the or equals to, so you should be thinking close circle. And then greater means you're going to go to the right. And there is my answer for the number line. So now you try it. And hopefully you get the same answer as I did. But if not, remember, always come and ask your teacher. So now, just like solving equations, there were some special cases that can happen. Well, those same things can happen with inequalities. So let's talk about what that would look like. So on our first one here, we're going to start off with distributive property. And then I'm going to add 6x to both sides. And you're going to notice, hey, my variables cancel out on both sides, so that means it's a special case. So let's look at what we're left. We are left with 15 is greater than 9. Well, is that true or is that false? That is most definitely true. So if it's true, hopefully you're saying to yourself, well, if it's true, that's either identity or infinitely many solutions. Now, if you say it's infinitely many solutions, that means every single number out there works. So when you make a number line, that means you are going to shade everything, both the left and the right side, because all numbers make it true. So let's look at the second one. Start with distributive property. And then after distributive property, I'm going to move my 4x, so I'm going to subtract it. And I get negative 5 is less than negative 6. Well, is that one true or is that one false? And you got to remember with negative numbers, it's actually false because negative 5 is closer to 0. So that means negative 5 is really bigger than negative 6. So if it's false, then you would say no solution. And remember, our symbol for no solution is a 0 with a slash through it. No solution means that there is not a number out there that works at all, ever. So that means when you graph it, your number line should be completely blank. There should be zero amount of shading because there isn't a number out there that works. So now pause the video and try the two try-its on your own. So once again, if you have questions on the try-it, please let me know. One more example. For this one, it says Derek wants to order some roses. For what number of roses is it less expensive to order from florist A? And then what number of roses would it be less to order from florist B? So I'm just going to say that I'm going to choose the variable X, and X is just going to stand for the number of roses. So let's look at florist A and florist B. So if I want florist A to be less expensive, that means which inequality symbol should I use? And hopefully you think to yourself, less than. So florist A, $4.75 per rose. So that means it has to have the variable X attached to it. The delivery fee is a one-time thing, so no variable, so just plus 40. And then less than, because remember we want that place to be cheaper. And florist B is $5.15 per rose, so make sure it has a variable X. And then the delivery charge is a one-time fee, so plus 25. So I'm going to subtract $5.15 X on both sides, and I come up with negative 40 cents X plus 40 is less than 25. Now I'm going to subtract 40 on both sides. So negative 40 cents X is less than negative 15. Divide both sides by negative 0.40. And remember, I'm dividing by a negative, so it should flip my inequality. And if I divide that out, I get positive 37.5. So that means florist A is cheaper if you buy more than 37 roses. Okay, remember you can't buy half a rose, so we don't have to worry about that. It's just saying you have to buy more than 37. Now, it does say, well, when is florist B cheaper? Well, florist B would be cheaper if you purchased less than 37 roses. So florist B is cheaper if you buy less than 37 roses. And with word problems, you do not have to graph on a number line. Okay, so you'll notice that there is no graphing on a number line. So there's your two answers. And as always, if you have questions, please let me know. Thanks for viewing the video.